Now the question is, what's the terminal point of this vector when we have a value of t? So if we have t, how do we calculate the terminal point of the vector? And that's going to tell us just exactly how to characterize this line. Okay, well, terminal point is, well, okay, v is 8k in this case. Then the terminal point is what? It's 5i plus 9j plus 6k, this vector, plus tv. Okay, plus tv. Okay, your terminal point of this vector is clearly going to have x coordinate 5, y coordinate 9, and the z coordinate is going to be 6 plus 8t. Again, tv would be 8k. So tv would be 8t times k. So that means that the z coordinate is going to change by 8t. So the point will be 5, 9, 6 plus 8t. That'll be the coordinate form of the point. And we could break that into three equations. X equals 5, obviously, and y equals 9. And what's z equal? 6 plus 8t. So the terminal point of this vector, if v is our 8k vector, will be 5, 9, 6 plus 8t. And these three equations will describe the line completely. And we call these the parametric equations of the line. Now in general, the x will also be a function of t, the y will be a function of t. But we're taking t times a constant vector, which means you're going to have t times the x component, t times the y component, t times the z component. So that the x would be, in this case, if v was something with a non-zero x, y, and z component, it would be 5 plus t times the x component, 9 plus t times the y component, and so forth. Now we'll talk a little bit more about that. But in general, this set of parametric equations will be a set of linear equations in t. So if you know the value of t, you can find the value of x, the value of y, and the value of z. Similarly, if you know the value of either x, y, or z, you can find the value of t, which can then be used to find the coordinates of the other 2 points. Now we'll move into a little bit about that.